Hi, my name is Peter Pilgrim, and welcome to JavaPolis 2006. Enjoy this one especially from me.
Very objective is working on JRuby. So we're working on getting a 1.0 release out at some point here, and helping to advance dynamic languages and advance Ruby on the Java platform as much as possible. We both have about 10 years of Java experience. We've been doing this stuff for a while. And previously I was doing Java EE work. I guess they called me a Java EE architect, whatever that means. And Tom was doing some web application development, same sort of role, same sort of capacity. And we both have a lot of other experience with other languages and other platforms. So we bring that to the JRuby development process. So here's a quick agenda. We are going to talk a little bit about what Ruby is, and then give a quick introduction to JRuby and what Ruby on the Java platform actually looks and feels like. And then we'll show a little short JRuby demonstration, doing some Ruby calling into Java code. And then we'll shift gears a little bit and talk a bit about the Ruby on Rails framework and how it's changing the way people do web application development. Show a demonstration of actually bringing up a JRuby on Rails application. And then we'll talk about some of the future plans for JRuby, including some of the work that's being done on NetBeans and some of the plans for JRuby itself. And then hopefully we'll have some time for questions and answers at the end. So, what is Ruby? Well, this is a quote from Ruby's own homepage. They say it's a dynamic, open source programming language with a focus on simplicity and productivity. It has an elegant syntax that is natural to read and easy to write. And now, of course, pretty much any language designer is going to claim almost exactly the same thing about their language, but being the Rubyists that we are, we believe that Ruby, more than other languages, actually fulfills this promise. And hopefully by the end of the talk you'll see that it does as well. Ruby is also a very interesting and colorful and growing community. These three are some of the usual faces you'll see involved in Ruby world. On the left is Yukihiro Matsumoto from Japan. He wrote the Ruby language and is the current benevolent dictator that continues to carry it forward. In the middle, some of you may recognize David Heinemeier Hansen, who invented the Rails framework and who continues to guide its development. A very interesting character, and certainly the fame from Rails has not hurt him at all. And on the far right, we have a character, definitely a character, who goes by the name Y the Lucky Stiff. And most people end up just calling him Y. Actually, when you talk to him, you say, Y, how's it going? He is another of the more colorful characters from the Ruby world. He's sort of a programming performance artist, and one of his claims to fame is the poignant guide to Ruby, which he helps teach Ruby to aspiring developers using his cartoon foxes. And this is one of the little comic strips that he has on poignantguide.net, which is his quick and hopefully painless ride through Ruby with cartoon foxes. He's indicative of the sort of creative and interesting folks that you find in the Ruby world. There's lots of them. There's certainly not just him, but he's one of the most obvious.
Highly recommended. Even if you decide you don't want to go and look at Ruby anymore, go and read it, because it's a totally different style of technical writing. I kind of hope it actually catches on.
Yeah, absolutely. It's definitely a more fun way to learn a language. And that's one of the things that Ruby really tries to push, is that it is a fun thing, fun language to work with. So,
Program can change over its lifetime. So, one of the casualties of a complex system, one of the first casualties of any complex system is the understandable performance model. So simple systems have simple performance models, complex systems have complex performance models. JVMs have gotten pretty complex, and so one of the prices that we pay for the performance that we get is it becomes much harder to theorize about and measure the performance of Java programs. It means, for example, that the performance of a class is going to vary not only on what it does, but how it's used by other classes, which is great because that means that you're always getting the most optimization that the JVM can give you. but makes your life a lot harder if you're trying to actually measure performance. So let's look at one particular optimization called monomorphic call transformation, that, and how both it can dramatically improve performance and it can really confuse you when you try to write benchmarks. So let's say you have a method foo in some class, and there's no method, it is no class that overrides foo. So there's no subclass of, that overrides the foo method. So now the JVM can look at it and say, okay, well this is a virtual method, but I know there's only one place I'm ever going to jump to. So I'm going to compile my code, instead of using a virtual call, which is actually pretty hard to optimize and very hard to inline, I'm going to turn that into a direct call that I can inline more effectively. And I'm going to count on the fact that the JVM is in charge of class loading, so if someone later loads a class that overrides this method, the JVM will find out about that and be able to invalidate the compiled code, the code that's based on this no longer valid optimization, and recompile it. Okay. Now this sounds, pretty scary, right? I mean, you're making an assumption that you know is true now, but you don't know is true later, and you're counting on the fact that you can back it out later if it becomes false. And this is a critical optimization without which Java performance would be terrible. And there are a number of other similar optimizations that the compiler can make speculatively, where it'll say, well, I don't know if this is always true, but I think it's true now, so I'm going to press forward with that assumption, and I'll figure it out when it becomes false. So let's take a look at an example. Can you read this code in the back? Yeah? That's not too bad. So here we have an example. We have an interface called operator, has one method called operate, and we have three different implementations of this method, each of which are going to add one to its operand. Okay, and the differences between them are pretty silly, right? So the first version adds one in the straightforward way, and then the second, sort of the Xenos method, where you're adding 0.5 twice. And the third is the roundabout way, where you add 2 and subtract 1. Now, let's ignore the fact that we all know that the compiler is going to do constant folding and compile these down to the same bytecode. But okay. So we have this little benchmark method, which what it does is it observes the time, it runs like 5 million iterations, and then observes the time again and prints out the difference. And then we have a main method, a driver method, that instantiates the roundabout adder and then calls our benchmark method. And to be safe, we throw away the first results because we want to make sure that things are all warmed up and compiled before we start actually measuring. And then we do the same with the other two implementations, simple adder and double adder. So theoretically, I should get the same numbers for each of these, right? Because they're performing identical computations. So let's take a look at what the results were. And you find that the straightforward way took 88 milliseconds. The go half and then half again way was measurably faster. And the clear winner was the roundabout approach, 6 times better, which was add 2 and subtract 1. All right, so how many people are going to go out and change your programs tomorrow as a result of this? All right, a few optimists in the crowd. So, okay, so what happened? All right, now this is like the absolute best case that could come out of a performance test, where you get a result that's so obviously bogus that you're not tempted to believe it. The worst case is when you're writing a program to settle a bet with your office mate, where you say this is faster, he says that's faster, so you write a program, and sure enough, yours is 30% faster, right? And you're not going to think about it anymore. Right? You're not going to ask yourself, was that a really good test program or did I just get lucky? You're just going to say, see, I knew it, pay up. Right? So the lucky case is when you get a number that's so obviously bogus it couldn't possibly be right. So let's look at what could have happened. Okay, let's go back to the code. So the first one, we instantiate a roundabout adder, we do our warm-up, and what's going to happen is the JVM is going to say, hey, okay, there's only one class loaded that implements operator. So I don't have to do virtual method calls when I call operate. I can do direct method calls. And so it can optimize away all that virtual method dispatch. Then when I get down to say, SA equals new simple adder, the JVM realizes that its assumption has been undermined, and it throws away the code for anything that might depend on operator, including the code for the run a bunch benchmark method. So the performance we get with simple adder is much worse. And then by the time we run it with double adder, well, at least the run a bunch code is already warmed up and compiled, so double adder shows up as being a little bit faster. Okay, this is probably not the result you expected. This stuff is really tricky and really subtle, and JVMs are really smart. They're going to go pretty far out of their way to do the best they possibly can, even if it's not really what you want. Another problem that tends to plague benchmarks is dead code. Benchmarks usually don't do anything, and JVMs are very good at eliminating dead code. And so you'll notice that one of the tricks here that I use when I print out the runtime, I also print out the result of the computation and just say ignore this. If I didn't do that, the JVM would be free to observe that the value of D is never used, and the operate method has no side effects, so it can optimize away the whole loop. And it will. Okay? So if you write a benchmark, every value you calculate must be used. And by used, I mean printed out. Because, or print out something that depends on it. Otherwise, JVMs are really, really clever about finding dead code, and benchmarks are, unless you work really hard, all dead code. Okay? And like I said, the lucky case is you get a runtime of 0 and you know that, oh, something really went wrong here. The unlucky case is like, 40% of your code gets excised and you have no idea. So, the moral of the story is, if you want to write micro benchmarks for Java code, that's fine. You just need to be able to think like a JVM. You need to be able to predict all the things that the JVM is going to do to your code. JVMs are pretty smart, and you better be prepared to, to match wits with it, because, otherwise you're probably going to lose and not even realize it. So, the reason these optimizations are so valuable, by the way, is that they encourage inlining. And inlining enables a lot of other optimizations. So if you're able to inline a method, that may enable other optimizations like dead code elimination or code motion or loop unrolling or any number. Basically, you're giving the optimizer a much bigger basic block to work with. So all these other optimizations then come into play. Whereas if you have virtual method calls that you can't devirtualize and all these method bodies are small, you're not going to be able to get the full power of the optimizations that the JVM is able to make. So the JVM is going to go to great lengths to try to devirtualize calls and inline virtual calls, which, like I said, most of the time is great. It means your programs will perform better. The cost is being able to understand and predict the performance is often a lot harder. Another thing that tends to interfere with micro benchmarks is garbage collection. Typically, you want to make sure that you run your test for long enough that you experience many garbage collection cycles. Otherwise, if you're sort of on that threshold between 0 and 1 garbage collection cycle, you can really distort the runtime.
This is JavaPolis. A mess. And this is me. JavaPolis is located inside the Metroplex cinema. It's a multiple complex cinema with huge screens, and you can see as I'm heading off this way there's a guy, there's that Brazilian guy again. He always wears a Brazilian flag. Yeah. Ronaldo! Ronaldinho! Okay. And if you like, you can have popcorn. I'm heading off downstairs now to the exhibition that they have here. So this is a very quick tour of the exhibition. Actually, I'm off to get a can of drink. This is BA stand. A couple of ladies here. This is Red Hat. Quick look at Red Hat. There's Mark Flurry around now. This is the big Oracle stand. Adobe, sorry. Oracle's here. And over here is Sun. Yeah, Glassfish is cool. And somewhere else is interface 21. Going behind the BA stand. Oh, right. I thought you said the bag. I thought you said the bag stand.
No, it's the back base.
Back base.
It's the back base. Next to the back base, you find back base.
This is, I think they're Ajax.
It's all about Ajax.
Oh, Ajax, yeah. 2 kicks. Web 2.0.
Web 2.0?
Yeah.
Or specifically rich internet.
Rich internet, definitely, definitely.
If you want rich internet applications, yeah, the only way to go is back base.
Yeah. All right, thank you. Thanks very much.
All right.
Bye.
Have fun.
I will. And this is where you get your bags from.
Did you get 2? Yeah, sure, no problem.
You can't get more than one.
Greedy.
But you can get a cup.
Thank you.
I think I'll get my cup. A mug.
Yes, a mug.
But I have to get your...
Can I have the scissors, please?
Moment.
And what happens is that in order to get your mug,
Okay,
you get it. You get
big
cut.
scissors?
Yeah.
look.
So,
Yeah.
I don't want to
For
buy.
you.
Me.
Thank you.
That's a mug. I can take a mug now. There you go.
There you go.
There you go. JavaPolis mug. I got mine. Woo, bye. Yeah, this is me and Phil. We're both in the movie together. He's just done his presentation. Doing his thing. He's writing more write code as we speak. Yeah. Get into it. Spank that. Taken with, I don't know, it's not Duke. Anyway, let's get up the stairs now and not kill myself. I'm heading back. I'm heading off to my meeting, to my presentation. Duncan Mills is doing data binding. And these are all the whiteboards here. Behind those whiteboards are, you can sit down and plug in your laptop. Say hello, mate. And all this is all about what people want to add into Java language. So there you go. JSR 227 standard data bindings by Duncan Mills.
And they may be annotation based. So, for instance, the JRuby framework is an example of that. We can use annotations to somehow add extra metadata to our domain model to provide some kind of linkage with the UI. Services, and this is really just a small subset. So yes, obviously we have enterprise Java beans. We may have a POJO-based persistence framework like Toplink or Hibernate. We may have specialized frameworks like Oracle's ADF Business Components, which is a declarative relational mapping framework. Or, we may be going down to the level of having domain models based purely on our own homegrown POJOs or interfaces. And of course, web services, BPL processes, all of these things are consumable service providers. I want to be able to deal with all of those things in a common way. And likewise, from the point of view of consuming those services, well, should it matter to me when I'm binding into a particular kind of UI, where that service is coming from? And should it matter what kind of UI I'm building? So, if you like, the principle behind what we're talking about doesn't matter so much if you're only concerned with one very narrow stripe of technology that you always use. But ideally, we want to have something that will work in all of these configurations. So if I'm building a Swing application, I want to be using the same binding techniques as I'm using when I'm building a JSP structs application, or a Flash application, or even something like an application written in Excel accessing Java Web Services. These are all valid technology combinations, and how are we going to solve that problem? So this, if you like, is the purpose behind the JSR. And this is a high-level diagram. This actually, apart from being slightly out of focus, is all you need to take away. If you take away this image in your mind, plus, of course, the marvelous demo I'll do later, you've really got a good summary of what the JSR is all about. We have this concept of, I've got my application front end written in whatever technology. It's talking to a thing called the data binding facility. And we'll be explaining what each of these things is in a moment. But that's exposing some interface to a binding object. Those bindings in turn are talking to another set of interfaces called data controls. And then finally, behind the data control, you have the actual provider of the service. So what we're dealing with here is a set of abstractions. I have some abstraction that defines the service and the data control, and I have another abstraction which defines how those data controls are actually consumed by the page or by the UI artifact I'm building. So of course it may not be a page. So we'll drill down on those, but before I do that, let's just do the disclaimer bit. I'm dealing with this subject from a somewhat privileged position of being able to see the documentation that the expert group currently has together on this JSR. The actual specification itself should be coming out in public draft really soon, so I've been told, again. And I think I said that last year, didn't I? But, so I've got access to the reference implementation and the documentation. But what I have access to is not the final version. It's not the ratified version that the expert group has agreed will be the public draft. So there may be slight discrepancies in what you see here in terms of the interfaces I'm presenting and with what will actually appear in a month or so's time. However, that aside, it's going to give you a fairly good idea of the scope and the context of what the JSR is all about. So the first thing we'll look at then is basically departments, employees, locations, that kind of stuff. Right? So what I've already done is set up one service layer which is using, as it happens, ADF business components as an object relational mapping framework. And what I wanted to show was that we can mix and match that with, say, an EJB session being doing the same kind of thing. So I'll have some data already exposed through one service, and then I'm going to expose some separate data through an EJB. So I'll very quickly put together a JPA persisted entity. So this is very similar. Those of you who were in Omar's keynote earlier would have seen him do pretty much the same thing. So we can very quickly reverse engineer an entity from the table, or we could build it manually. I'll just do it from the table to save time. From the HR schema is good, and we'll just pull in the employees object. So we'll go away, look at the database, reverse engineer a POJO out of that and annotate it for you. So there's my simple beam with the various attributes all annotated to map the disparity between the kind of standard Oracle style column naming conventions and the more conventional Java naming conventions we'd have for attributes, which is why I've got all of these column annotations, and getters and setters for all of those. So okay, I've got my object. I'm just going to make it a bit more interesting. We'll just save myself a little bit of time and pull in a new name query. Because what I want to do here is, rather than finding all employees, I want to have this service only expose employees that are within a certain department. So there's my entity. We'll very quickly create the session bean to wrap that thing up. Okay, and in fact we can just let all that happen. If we just look at what's been exposed here, we've got my find by department ID finder generated out of that finder I just put in as an annotation, and then the various boilerplate methods that get generated to manage creation and update and removal of new instances of entities. So there's my service. So that's an EJB that's now runnable. And I can go ahead and kind of use that in the conventional manner. But what if I want to use it using this kind of data binding? So all I have to do here is to expose this thing as data control. I can either do this off the context menu, or I can do it by just dragging and dropping, deciding which interface I'm going to use, whether local or remote. We'll stick to local for now. And what this goes away and does for me is generate up a bunch of XML metadata. So again, this is something that is specific to this implementation of the standard, or the proposed standard, I should say. So one thing that the standard doesn't mandate is how the data controls and how the bindings objects should actually be themselves defined and created. The interfaces that are laid down by the standard are purely the runtime objects, and how they're arrived at is up to the implementers. So the way we do this within JDeveloper and the ADF framework is using an XML-based scheme. So we have a description of the service in XML. We can just go away and look at that. And we can see here how we have elements within the XML document that pretty well map onto the things I've been talking about. So we have a method accessor, well, that describes an operation that is exposed via the service. And we've got various bits of metadata in there which are describing the return types and the parameters and so on. And if I have individual attributes, then likewise they'll be exposed through there as well. Now, one of the reasons for having this additional XML metadata is quite important, because you might say to me, well, you've got a thing that is essentially a POJO that's your session bean. Well, why can't you just introspect that at runtime and create these objects on the fly? And that's certainly an approach you can take. And an implementation of the standard could certainly go down that route. But of course, if you're dealing with services that are themselves purely defined in some form of metadata and aren't available in a form that you can introspect at runtime, then you've got a solution that doesn't work across the board. You've got a solution which is confined to a certain stack. So having this kind of generic description in XML works pretty well for the way we've implemented the standard proposal. So I've got a definition of the session bean itself, and also that generated up for me an XML definition of the actual JPA entity in terms of describing the attributes and the types. So again, this is something you can do with introspection. We choose to do it up front like this, because one of the advantages there is I can start to do things like decorate this with things like explicit validation or security. So if this is a web service, for example, where I didn't have access to that underlying entity, I can go away and add this extra decoration on, which would just get stored in the XML metadata, and then at runtime, those data control description objects would then be further decorated with the runtime implementations of that metadata. So I've got two services now. In fact, if we go into the UI and start to build something, so I'll just create a very simple JSF page as an example. I don't think it really matters what we call it. As a page developer, what I'm going to be confronted with now is a data control palette, which is going to give me a view on all of the services that I can consume. So I've got a conventional component palette here where I can start to lay out, in this case, my JSF UI. I used the wrong component. I wanted panel page because it's much prettier. Get rid of that one. Pull that one in. Yeah, oops. Okay, so I do a bit of basic JSF work using JDeveloper's Visual Editor. Fine, I've got my UI. I now want to bind data into that, which is really the interesting bit. So those services that I've exposed via data controls are available to me in this thing called the data control palette. And what this palette does is it looks at that metadata that we've already defined for the service, the data control metadata, and if you like, redisplays the actual service to me in a way I can use directly within my user interface. So probably the best representation is here in the business components one, where I've got essentially two collections of data. A query that's returning all locations, another one that's returning all departments. I can explode that. I can look at individual attributes. I can explode the operations that are connected with an operation, with a particular collection. So here's where we're seeing the concept of those standard operations come into play. I've got, with this collection here, I've got these standard operations to navigate through the collection, to add new rows in, delete rows, and so on. As I said, outside of what the specification covers right now, but kind of an indication of where it could go. And likewise, I've got some top-level operations at the data control level. This is a transactional data control, so it has these commit and rollback methods exposed as standard features. So the data control palette is just re-visualizing that service that the data control is proxying for in a standardized way. And then I can go ahead and pull something like, for instance, either a whole collection or an individual attribute into the page. If I pull that collection in, and when I drag and drop in this case, what JDeveloper does for me is look at the thing I'm dropping, and then if that thing is a collection, then it's going to give me various kinds of UI I can drop out of it, such as a form or a tabular layout or a navigation control. Or if it's an individual attribute, it may look at the data type of the attribute and decide whether I can drop this thing as just a plain text field or maybe a text field with a date picker attached if it's a date data type. So I can take this, it's asking me, okay, which attributes that are exposed by the data control in this collection are actually interesting. I don't really care about manager ID and location ID in this particular instance. Okay. So this then does two things. First of all, it generates up a bit of UI. So we're in Java Server Faces here. So we've got some output text components, some command buttons. And then we see references here to that bindings key that's maintained by the binding context. And how this actually all works is that behind the scenes, as well as creating this bit of UI for me, we also got a thing called a page definition, which is another set of XML metadata. So we had the first set of XML metadata which describe my services, which at runtime gets transformed into the runtime data control objects. And then correspondingly here in the page definition, I've got what essentially describes my binding container. I've got all of the attributes that I'm interested in, all of the methods that I'm interested in within this page. So that metadata there is essentially what's going to be run through when I navigate to this page, and all of the relevant lookups will be done at that point in time. Just to make life interesting, I'll also bind in something from our EJB-based control. So there's my query employee find by department ID finder, and I can take the collection that's a result of that, my employees collection, and drag that onto the same page as well. So we're mixing two totally different services on the same page here, one from ADF Business Components, one from the session bean. I could equally drop in, web services, POJOs, you name it. We'll drop this one just a read-only table. But importantly, in this case, we access that collection as a result of a method call. And that method call, so the call to find by department ID, expects as a parameter. So this is where I'm invoking an operation binding and then getting a result back from that operation binding, and then I've got a range binding against that result set. So what I want to do now is just wire, if you like, the two data controls together almost. So I can say, well, okay, I want to pass in the value that's currently defined in the page as the department ID. So I can, just using the expression language browser within the IDE, I can say, well, okay, the thing I'm interested in to bind and pass as an argument to the session bean method is the department ID. And it exposes a standard attribute called input value, which will be the underlying object, or underlying object that particular attribute represents. And I just need to do a bit of data type conversion here, because I know for a fact that that thing that's returned by input value happens to be of one particular type, which is Oracle JDO number, and I really just want it as a straight long, so I can just call the get value accessor on that thing. So that's done the wiring. So what I've now got is when I just set up the project for stuff I need, and we'll clean this up a bit because I really don't need all of these fields. That particular method call are going to be returned as a range binding, and I'll use that to populate this table. So I've now effectively got a master detail relationship across two totally separate services. And I get this right about 50% of the time, so we'll see if I've forgotten something. We'll just run that up within the IDE, scrolling through. I knew I'd get it wrong. Never mind. Okay, I'll worry about that.
Primary objective is working on JRuby. So we're working on getting a 1.0 release out at some point here, and helping to advance dynamic languages and advance Ruby on the Java platform as much as possible. We both have about